Welcome to the SaferAfrica learning courses. My name is Sandra Vieira Gomes and I am a researcher from the National Laboratory of Civil Engineering of Portugal in the field of road safety. I will be your guide in Module 4 on safer roads. The Level 1 e-learning courses developed within this project are divided in 7 modules: concepts of road safety, data collection, road safety management, safe roads, safe users, safe vehicles, and finally post-crash care. You are now watching to the Module 4 on safe roads. This model includes 5 different sessions on road life cycle and general instruments for safety interventions at each stage, the driving task as related to road environment, impact of the safe system principles in road environment different stages, crash contributing factors related to the road environment, and methodologies to assess the effects of interventions.
Within Module 2, about the driving task as related to the road environment, I'm going to talk about driver's expectancy aspects and also about traffic calming measures. We are now entering the first part about the driver's expectancy in what relates to the road environment.
From the road safety point of view, in any kind of road intervention, 4 main concerns or fundamental principles are relevant. The use of the infrastructure must be properly ordered. The road environment must be adapted to the type of use it is subject to. The characteristics of the road environment must be adapted to the psychophysiological characteristics of the human being. Conservation and maintenance activities must be performed to ensure that the initial characteristics and safety levels do not degrade in an unacceptable manner.
The first two concerns, an order infrastructure and the road environment adapted to the type of use, are related to the need of adapting the road environment to the previously expectations of drivers. This expectation is built in the driver's lifetime, and as so it is very difficult to be changed through local interventions. It is therefore important to assure a correct hierarchy of the road network and the proper differentiation of their characteristics, so that the driver can easily identify the proper behavior to each road. The third concern is related to 2 premises. It is important to assure that no demands are made on users which exceed their psychological capacities, and the driver's ad hoc expectation must not be compromised. Ad hoc expectation is a short-term expectation that the driver develops in the route he is driving on, which is based on the characteristics of the road and of the traffic that the driver is encountering. This ad hoc expectation can be violated, for instance, when after a long stretch of road with curves and big radios, a sudden small radio curve comes up. We are now entering the traffic calming measures section. There is not one single overall accepted definition of traffic calming. Some definitions are expressed in terms of objective, whereas others are expressed in terms of measures. The objectives generally refer to elements such as improving traffic safety, increasing livability, and protecting the environment. Measures generally refer to local speed control and other measures of traffic restraint, but may, more widely, also include network planning, parking policies, and stimulating the use of alternative transport modes. Traffic calming measures are usually categorized according to the following structure: changes in horizontal alignments, changes in vertical alignments, and I added a third group where fall all the other measures that can be classified within the first 2 groups. Changes in horizontal alignments may include lane narrowing, curb extension, chicanes, parking facilities, pedestrian medians, and roundabouts. Lane narrowing is a reduction of the carriageway width through the widening of other parts of the cross-section, like crosswalks, parking space, central access, or others. They are suitable for residential areas and should not be applied in curves or areas with big or high parking needs, as it may be illegally used for parking. It is a solution with positive effects at pedestrian crossings, as it reduces the crossing distance. It is also a measure which in generally is well accepted by those involved in emergency situations because they have a relatively small impact on the trajectories of vehicles and do not require a sudden reduction in speed. Curb extensions are extensions of the sidewalk, usually implemented at intersections which improve pedestrian visibility and reduce their crossing distance. An expansion of the curb line into the lane of the roadway adjacent to the curb can reduce speeds of turning vehicles and offers protection to pedestrians. This solution also creates space that may be used to locate street furniture, bike parking, amongst others, and also physically prevents illegal parking near intersections and crossings. Chicanes are artificial turns created to slow traffic. They lead to a reduction in the width of the roadway, either on one or both sides of the road, creating a zigzag that directs drivers away from a straight line, which can reduce vehicular speeds. Available data from chicane schemes indicated a 54% reduction in injury crashes. Additional benefits can be stated. It forces drivers to drive more slowly and with greater awareness, particularly in mid-block locations, can green and beautify the streetscape with trees and vegetation, improving environmental quality, and has a minimal impact on emergency response vehicles compared to speed humps and other vertical deflection measures. Medians with pedestrian refugees have the double benefit of inducing a speed reduction and simultaneously to make pedestrian crossings safer. It is a good solution for roads with a significant width, particularly for two-way roads. This division enables pedestrians to cross in two phases, which can pay attention only to one direction at a time. Another solution of traffic calming are roundabouts. Roundabouts are generally circular central islands in the middle of an intersection. Entering traffic must typically alter direction and speed to avoid the island, creating a circular flow in one direction. This solution brings several benefits: reduction of speed, reduction of the number and severity of collisions, an improvement of traffic flow efficiency for intersections that handle a high number of left turns. In most applications, roundabouts replace the stop lights and traffic signs that regulate flow in other intersections. They are more appropriate for streets with one lane in each direction and can be problematic if applied to multiple lane streets. Roundabouts should maintain sufficient space for pedestrian crosswalks, and crossings should retain a linear path of travel. The circles should be designed to allow larger vehicles to run over their outer edge. Measures that produce changes in vertical alignments can also provoke a speed reduction. As an example, I am going to talk about rumble strips, speed humps, and raised intersections. Rumble strips are closely spaced raised pavement markers at regular intervals on the roadway that creates noise and vibration to the vehicle. Transverse rumble strips are used to alert drivers of an unexpected change in the roadway, such as the need to change lanes, slow down or stop, or changes in the roadway alignment. Typical locations for these rumble strips are on approaches to intersections, toll plazas, horizontal curves, and work zones. These rumble strips are not intended to reduce run-off road crashes. For this effect, rumble strips should be placed in the edge line or center line. Speed humps are transversal elevations in the pavement that can reduce vehicle speeds to a certain limit based on the height and length of the hump. These solutions have a low cost and require minimum maintenance. However, it should be mentioned that speed humps are a major problem for emergency vehicles such as ambulances and fire engines, namely in what concerns the discomfort to ambulance passengers and the delay induced to response times. They can also cause atmospheric pollution from the speeding up and slowing down of traffic between the humps, and complaints have been registered about the additional traffic noise they generate. Speed humps are frequently used on residential and local streets to reduce speeds, but they can be used on arterials as well. They are not recommended if sight distance is limited and if the street is on a steep grade. Studies from Norway show that humps reduce the number of injury crashes for a given amount of traffic by around 50%. However, they should be considered as part of a great area-wide traffic calming scheme. Speed humps can be associated to pedestrian crossings, in which case they also improve pedestrian safety. Here's another example of a raised pedestrian crossing, this time with changes in the macro texture of the pavement that also alerts drivers and creates some discomfort when they drive in high speeds. In raised intersections, the intersection area is raised to the same level as the surrounding pavement in order to reduce vehicle speeds, also enhancing pedestrian environment and crossing safety. The slope of the entrance ramps for motorized vehicles can be steep or shallow, depending on target speeds, but is normally raised to the vertical level of the curb. It is common to use different paving materials to further draw attention to raised intersections. Appropriate warning signs and roadway markings should accompany raised crossings. It is ideally suited for stop control intersections with a high volume of pedestrian crossings and low target vehicle speed, such as transit stops, commercial areas, residential neighborhoods, or schools. In the other measures sections, I've included different types of measures, like gates, partial or total road closures, speed control traffic lights, radars, road markings and surface treatments, and road lighting. Gates are transitional areas, usually located at the border of urban areas, for beyond which a different behavior is required. It is usual to use vertical elements with some importance or visibility so that they are understood by the drivers as a true transition in the road. These gates are usually combined with other traffic calming solutions such as lane narrowing or pavements with different textures. Roundabouts can also act like gates, marking the transition to an urban zone and simultaneously forcing the reduction of speed. Partial or total closures of roads consist on rearranging traffic in a specific area with the installation of physical barriers for two-way or one-way traffic. They can be implemented only with signs, vertical or horizontal, or materialized by extending sidewalks at intersections or installing barriers or islands in the roadway. The use of speed control systems combined with traffic lights is an effective way of imposing a speed limit. Speed control can be achieved by installing sensors on the pavement or by radar detection systems installed in the support structure. The signal turns to red if the drivers exceed the speed limit. They should be combined with previously placed vertical signs indicating the maximum permitted speed. Speed radars are another traffic calming solution. They can be used as surveillance tools used by police forces or as deterrents to inform drivers of the speed they are traveling by activating light signals. The systems should be combined with graphic warnings of the maximum speed allowed on the spot. Road markings and surface treatments are specific markings that can be adopted to inform or induce drivers to adapt their speeds to a particular context. For instance, surface treatments with different pavement colorations and rough textures, thermoplastic signs applied to the pavement, or chromatic paintings that create a narrowing effect. Despite their relatively low cost, they are usually lack of systematic maintenance. Driving at night only using headlights as the sole source of illumination is quite difficult, since the visibility is reduced both frontally and laterally. If driving is done at the same speed as in daytime periods, safety margins are considerably reduced and measures should be taken to significantly improve the driver's orientation. Public street lighting is used to provide sufficient light for drivers to travel safely and comfortably. The application of this solution is more common in areas where traffic of vehicles mixes with pedestrians or bicycles. Finally, within traffic calming measures, we can talk about areas that are created with a combination of several of the previously mentioned measures and with changes in the road environment allowing a safe coexistence between all the road users. This global solution was first implemented in the Netherlands and it was called as WUNERV. WUNERV zones are zones where there is no physical distinction between motorized traffic and other modes of transport. The speed limit is about 15 km per hour and applied to local access roads located in residential areas. Although priority is given to pedestrians, motor vehicles have the right of access to these areas, but drivers are forced to slow down and be cautious. This is all for the session 2 on the driving task as related to the road environment. Thank you for your attention. You can download a PDF of this presentation from the website and also a PDF with reference and further readings on this subject. I invite you to watch the next session on the safe roads, impact of safe system principles in road environments life cycle.